Hello, I am Seema and welcome to part 35 of the chapter Organic Chemistry, Some Basic Principles and Techniques. We have been discussing the different methods of purification of organic compounds, and in the past 5 or 6 videos I have explained the different methods, that is sublimation, crystallization, distillation, differential extraction, and the fifth and the last method of separation or purification of compounds is chromatography. In this video and in the next one, I will be explaining chromatography to you. So the first 4 methods, that is sublimation, crystallization, distillation and differential extraction, I have already discussed in the previous videos. So I would encourage you to go back and watch those methods. So now we come to chromatography. Chroma is a Greek word and it means color. What are we doing? What is our topic? We are separating or we are purifying compounds. So we are separating the components of a mixture. A compound, when it's present with another compound or another component, it means it is impure. So we are separating the components of a mixture. So chromatography is also a method of purification of compounds. And chroma means color. So how do you relate the two? It is a method that is based on separating compounds that have different colors based on their color. So either the compound is colorless and it reacts with something which gives it color, or it is a colorful compound. It itself has color and you can separate it using certain technique which is known as chromatography. So if chroma is color, the graph is more like sections. You know, what do you see in a graph? Things which have been divided into sections. So you have a chromatograph. So chromatography is a technique in which colored compounds can be separated, or compounds can be separated on the basis of their color or the color they acquire when they react with something on a medium. On a medium, that medium may be the graph. We'll understand that as I explain this to you. So it is used to separate a mixture, purify it, or to test the purity of compounds. Sometimes it is used to separate a mixture, which is our aim, that we are purifying the substance. Therefore, we need to separate the components of a mixture. We need to purify. There is one substance which is important and the other thing is an impurity. If we can use this technique to separate them so that we get that compound that we want in the pure form. So we use it to purify, we use it to separate components of a mixture, or if we have been given a compound and we want to check if it is pure or not, we can use chromatography as a test, a technique to test the purity of the compound too. The biggest benefit of chromatography is that it does not need a lot of the mixture. With a very little amount, you can actually see if it is being used for test, or it is being used, you're only testing the purity, or you're checking if it is pure or not. You do not need to use all of the compound. You can do it with a very little quantity, so very little wastage. But if your aim is to separate the mixture, then of course you will be using all of it. It is obtained from a Greek word chroma, which means color. In this technique, a mixture of the substance is applied to a solid, liquid, stationary phase. Okay, before I really come to the technique, there are two. Not only is it based on color, a technique that is based on color, and we use the color to as the, it gives us the a visual impact of the substance has been separated. The other basic process which involves chromatography is adsorption. You know, if I have a sponge, you know how a sponge works. If I dip it in water or in a liquid, the sponge is a soft substance. You can see I can squeeze it. I can squeeze it because it is styrofoam and it has got big air bubbles in it. It has got holes in it, and therefore if I put it in water, it absorbs the water into those air spaces, and therefore all the water gets collected in the sponge. When I pick it out and I squeeze it, all that water comes out because I'm squeezing those air spaces. And when I squeeze the space, all the water comes out. This process is known as absorption, absorption. absorption. The other method is adsorption. And chromatography is based on this. The process of adsorption is used, just as in the case of distillation. The process that we used was distillation, that is vaporizing the substance and then condensing it and then collecting it. Here it is based on the process of adsorption. So what is adsorption? Unfortunately, I do not have a piece of chalk here. If you take a piece of chalk, and if you kind of get a chance or you get a chalk somewhere, try this at home. Put a little ink in a glass of water, or maybe even soy sauce. I will do it with the soy sauce. Take the piece of chalk and dip it in that solution of ink and water, or soy sauce and water. Hold it for about a minute. Take the chalk out and leave it out to dry. When it dries up, now break the piece of chalk. That was that part that was dipped into the ink. When you break it, what do you see? You see that if this is the chalk, I'm now talking of the chalk like this, you've cut it and you're seeing it inside. You will see the middle of the chalk is still white, but the outer surface, that has got the color of the ink. Only the outer portion has the ink. So if you look at the entire chalk, you will feel that all of it has turned pink. But when you break it and you see the center, the core of the chalk still remains white. So what has happened in this process? In this, the colored substance has only got absorbed on the surface. The ink has only absorbed on the surface. It has not gone in. This process of absorption only on the surface and not throughout the substance, like in sponge. In sponge, not only the surface is wet, inside also there is water. But in chalk, only the surface gets the color and the core remains white. This process is known as adsorption. I'll take another. I'll just demonstrate it here. I took some soy sauce in a glass of water. And I have this, a paper towel. I cut it. So I am going to insert the paper towel into this colored solution, which I made using soy sauce and water. Do you see? The water is rising in the paper towel. And do you see that it is getting, the color can be visible? I wonder if it is actually visible I can clearly see it. Do you see the top is white? And till here you can see the liquid rising and the color has risen till here. This is adsorption. So this is adsorption that has occurred. On the surface it happens, and the colored substance, if I would have kept it in this for a little longer, you would find that the paper towel keeps getting wet and wet, but till higher, but the color only rises up to here. Now the water has reached a higher place. It is still here. The water is here. If you see the line here, the water is still here, but the clear color that I see is only up to here. So what have I done? I have separated the soy sauce from the water with the help of this paper. This is chromatography. Using the colored substance and the other substance, the other component can be separated by the process of adsorption, not absorption. It's not like if I would have put the sponge in this, all of it would have got through, and if I squeezed it, the soy water would have come out in the same way. So it is a technique which is based on the process of adsorption. And so what do? This paper that we took, the solid. So this can be a solid, or it could even be a liquid. Sometimes you use gels. So which is a stationary phase. Did you see what was moving? The paper that I kept in the solution was static. So it was stationary. And what was moving? The water and the soy solution was moving through this. So that is the mobile phase. There is a mobile phase. So the solution which has to be separated makes the mobile phase. That is the mobile phase, and the substance that you're using to actually separate them is known as the stationary phase, because this does not move, only the solution moves through it. So we say a mixture of substance is applied to a solid or a liquid. I applied it to the solid or the liquid. I actually dipped it into the solution. And a stationary phase. into a solid liquid stationary phase. It is applied to a solid liquid stationary phase. Do you know, if I would have taken let us say the same paper towel, and I took a little ink, if you have an ink pen, we use most of ball pens these days, but if you had an ink pen, make a dot here, somewhere about an inch above this, and then dip it in pure water only about half an inch, and see, the ink will start rising. And along with the water, you will notice that the ink starts rising and it forms a trace. And if you say on the dot you mix red and blue ink, you do this in the laboratory. You mix a dot of red ink, a dot of blue ink at the same spot, and now dip it into the water. Both the inks will travel different distances and they will separate out on the paper. That paper is known as the chromatography paper. And this paper towel can also do the job. At home, if you want to try it out, you can do it with a paper towel. So, a stationary phase. A pure solvent, mixture or a gas is allowed to move slowly over the stationary phase. It could be a pure solvent, like it could be water, only water if you take the dots of ink, or it could be a mixture like I did with the soy and water, or this could also be a gaseous phase, that a gas is rising on the stationary phase. The stationary phase also could be a solid or a liquid. Is allowed to move slowly over the stationary phase to gradually separate the components. Slowly, the components will get separated. Now, chromatography can be classified into two types. The first is adsorption chromatography, which I just explained to you, and the second is partition chromatography. Both of them are actually based on adsorption only. You will understand this as I explain it to you. The first, that is adsorption chromatography, what is it based on? It is based on the fact that different compounds are adsorbed to different degrees. Different compounds, if you, let us say you had this, we use this, where the water traveled more than the soy sauce. Not the best example, the soy sauce is also now traveled all over. So, or if I had used ink and water, the ink would have traveled less and the water would have risen still higher. So it is based on the fact that different compounds are adsorbed to different degrees. Common adsorbents that are used in this case are silica gel and alumina. Normally, the stationary phase that is used for adsorption chromatography is silica gel and alumina. We'll be doing one of these here. The second category or the type of chromatography is partition chromatography. Partition chromatography is based on continuous differential partitioning of components of a mixture between the stationary and the mobile phase. It is a continuous separation that occurs. It is a continuous differential partitioning. The paper chromatography that I showed to you is actually a partition chromatography, where you see the different inks, one ink travels this much, the other colored ink is traveling that much, and then it stops and the solvent keeps going higher and higher. So a kind of partition is created. So it is based on a continuous differential partitioning that as the substance keeps getting absorbed through the surface of the substance, the partition keeps happening, and it's kind of a continuous process. At first, both the inks will rise, then one of the colors will stop here, then the second one will keep rising along with the water, that will stop there, and then the water will keep rising. So the partitions are being created as all of them are traveling together. So it is a continuous differential partitioning of components of a mixture between the stationary and mobile phases. The mobile phase is the solvent that is rising along with the compound that has to be separated. And the stationary phase is that surface that you're using for chromatography. It could be, in the case of adsorption chromatography, it could be silica gel and alumina. And in partition chromatography, we use the example of a chromatographic paper. The example here is paper chromatography. The rudimentary form of which I just showed you. So now we come to the first category of chromatography, that is adsorption chromatography. Adsorption chromatography is further of two types. One is known as column chromatography and the second is known as thin layer chromatography. So in this video, I'm going to discuss the first, that is column chromatography. In the next video, I'll be discussing thin layer chromatography and paper chromatography. Okay, so let us understand what column chromatography is. What is a column? If you take a long tube and fill it up with, let us say, silica gel. The gel is like a transparent, you see, a jelly. So the silica gel has been filled in it, and you have a mixture of compounds that have to be separated. These compounds are, let us say, A, B, and C. You took 3 compounds, a mixture of 3 compounds, and you filled it with silica gel. There's a stopcock in a burette in the bottom, and you filled it with silica gel. You added the mixture of 3 compounds, A plus B plus C, and on top of it, you added the mobile phase, that is the solvent. The solvent is the blue colored one. It could be water, it could be anything. Now, you call it the solvent, and what happens as the solvent passes through the mixture, it dissolves the compounds A, B, and C, and the A, B, and C start moving with the solvent. It is almost similar to the rising of the soy solution. You know, as I put it into the water along with the soy solution started raising in the paper. Here it is happening not against gravity, it is happening along with. It starts moving, it dissolves the compounds and starts moving downwards. And the silica gel absorbs the compounds. And each compound gets adsorbed to a different one is more adsorbed, has a greater absorbability, so it adsorbs first, the other one takes longer, and the third one takes even longer. So one gets least adsorbed and one gets really is good at adsorption. So let us say that A got adsorbed first. So the entire mixture moved down and then A was adsorbed. It stopped there because all of it got adsorbed. Now in the mixture, in that little sample of mixture, you are left with 2 other compounds that are B and C. So B and C travel with the solvent a further distance, and we find that B stops next, which means the most adsorbent was A, less than that was B, and the least adsorbent was C, which goes to the highest. The one that travels the most means it did not get adsorbed easily, it took longer to get adsorbed. And the one which got adsorbed easily will stop very quickly because that will be the first one to get adsorbed. So A, B, and C have now formed, you see in the entire column, you see the compounds have been separated in the column. And that is why it is given the name column chromatography. Right? Now, by this, what have we done? We have seen that there are 3 compounds and these 3 compounds have been separated. And we can see the 3 compounds separately. So now we know that the mixture we had got 3 compounds. But was that the aim? The aim was to purify the substance. The aim was to separate the components. We have separated them visually, but now of what use are these compounds to us? Because they are stuck in silica. They are stuck in the column. They are of no use to us. So if we want to use them, what will we do? We will start choosing eluents. And eluent is another solvent. The eluent you will choose in such a way that the eluent, let us say, you choose a solvent. You know now what are these 3 components, A, B, and C. You know this solvent dissolves only C. It does not dissolve A and B. I will first try to choose an eluent which will dissolve C, and it will not get adsorbed in silica gel. More than being adsorbed in silica gel, it will dissolve in the eluent, and as the eluent comes down, I open the stopcock. Along with the eluent, the compound C will come out. Then I will choose another eluent which will dissolve B but not A, and does not have any effect on silica or whatever is there. Now we add it to the top. It also travels through, has no effect on A, comes to B, dissolves B, passes down. You open the stopcock, you collect that compound with B. Now you get C with its eluent, B with its eluent. So again you got compounds which are actually, you have separated A, B and C, but now A, B and C will be mixtures of the compound with their eluent. So by distillation or by evaporation you will get the compound back. So you can get these compounds from the mixture of their eluent later by distillation. Similarly, you will choose the third eluent which would dissolve A but would not be affected by silica gel. It will dissolve all of the adsorbed A and come down, and you will collect that too. So this was column chromatography. Let me just read it. It involves the separation of a mixture over a column of adsorbent, that is the stationary phase. The adsorbent, that is silica gel, is the stationary phase. Or instead of silica gel, it could have been alumina also. Industrially, alumina is used a lot. Now it is packed in a glass tube. You've put it in a glass tube. The mixture adsorbed on the adsorbent is placed on the top of the adsorbent column. This mixture is placed on the top of the adsorbent, and an appropriate eluent is allowed to flow down the column slowly. The most readily adsorbed substances are retained near the top, and the others, they will come down. So you will use a solvent. The solvent will take it down. The language is a little confusing here. You feel the eluent is doing the job, but you use a solvent. The solvent dissolves all three compounds, makes it move along with it, and separates them because each one gets adsorbed at different places, at different heights. After that, you choose your eluents according to the compounds, and the eluent is a solvent which will dissolve one of these compounds, and then you can separate it out. So you will choose first the eluent which is not affected by this, the silica gel, not affected by A. The water, the solvent has been used by then. You can remove it by opening the stopcock. So when you add the eluent, you will collect A, B and C. So you would choose to collect C first because that's the lowest. So you'll choose an eluent for C, it will come out, then B, then A. So the substances are retained near the top and the others come down to various distances in the column. And this is known as column chromatography. With this, I'll wind up today's video, and I'll be explaining the other two chromatographies, that is paper chromatography, that is partition chromatography, and thin layer chromatography, the second kind in absorption chromatography, in the next video. So let me wind up the video. If you found it helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.